Hello, this time we're going to go over some of the computer vision code that I did. It was a senior level elective I took during college. It was pretty interesting. I really liked it. Two examples of code that I'm going to be going over are the Canny and the Sobel algorithms used for edge detection. So first, let's go over Sobel. Basically what we did in this program is we took in an image and then we did thresholding on the gradient magnitude to find the edges. So there's an assignment description you can kind of look at. Some of it was heavily edited when we were actually in the course, so the PDF might not really correspond to what was actually done for this program. But here's what's inside the repo. I downloaded a program so you can kind of view these PGM files, but basically this is what it looks like. I'm using the preview function in Mac OS X. This is the input file that I'm going to be using for Sobel. And basically here's the sample output of what it's going to be doing. I'm going to be looking for a magnitude of the edge. This is what it would look like with a low threshold, and this is what it's going to look like with a high threshold. And basically what the low and high threshold are doing is we're saying if we find any pixels who have a brightness that's above this threshold, then we're going to include it in the final image. So with a lower threshold, obviously we're going to get a lot more pixels, and with the higher threshold, we're going to get a lot less pixels. These are the brightest ones in the image. So that's what we're really seeing, and that's what we're looking for anyways. So for the Sobel code, let's look at that real quick. Sobel.c is what we're interested in. We have these masks to the pictures, x and y. We ask the user for their input and output. Here's the input file, and these are the three outputs you're going to be getting that we're going to be looking for. Here's some of the code that we go through, and eventually this is where you print it out to the different files, the low threshold and the high threshold. And here's the regular magnitude. So let's go ahead and compile that. We've got our executable down there. Let's go ahead and run that. So we're going to do a low threshold of 30 and a high threshold of, say, 90. And so here's our output files down here. So this is the magnitude. Looks pretty similar to our other output. Here's the low, and here's the high. So you can see these are pretty similar. I think 30 and 90 were the exact thresholds I used when I turned in the program before, so that's why these look very similar. It's just a practice taste. We can go ahead and run it again and do a low threshold of, say, how about 20, and high threshold of 75. So now what we should see is that the low has even more pixels included because the threshold was even lower, so 20 instead of 30, and the high should also have more. You can see it has a lot more than it did before in the sample output because I lowered the threshold. And that's it for Sobel, and now we're going to go ahead and do Canny. Quickly, before we move on to Canny, I just want to show you there's another sample input that we have that's this chess piece. This is what we're going to be using as the sample input for Canny, but here's Sobel's magnitude run on it, so you can kind of see the difference. Here's a low threshold with Sobel. You can see a lot of pixels. Here's a high threshold, so you can see there's a lot less pixels because the pixel intensity or brightness has to be really high for it to show up because of the threshold. Here's the X of it, the X mask, and here's the Y mask. So it's just really interesting. So now we're going to get into the Canny code, and basically there's another description document that you can put in here. We're going to be using the Canny algorithm for edge detection. This one we're also looking for the peaks. You can see the website for the course that I took is in here, so you can click that if you are interested in exploring what these sample input images are. They're all here, and of course you can navigate to the actual course website. This one's currently ongoing, so you can see the notes and read it and get a little bit of a free version of a computer vision course. Of course, professors are more interested in doing computer vision research than making their websites look good, but simple HTML does the job, so can't blame them. All right, so here's a little bit of the code. Once again, it's a little bit more complex to explain, but if you look through the notes, it's pretty simple after that. And it's a little bit of math, a little bit of matrix. If you take linear algebra and matrices, it should be pretty simple to understand how you get these threshold values and how you put the masks on the pictures. So real quick, let's compile this, and I'll show you the sample input that we're running is this chess piece, and we're going to be wanting to get 3 more things. We're going to be wanting to get this magnitude output of the chess pieces, the peaks from the picture, and the final edge detection case, which is perfect. Here's the edges of these pieces. That's exactly what we want. So let's go ahead and run that. Here's what we get. So here's the magnitude. Looks good. Here's the peaks down here. Looks the same to me. And the final. So that's basically how we go through 2 different algorithms, both Sobel and Canny, for computer vision, and get some different image inputs. There's additional images that you can test if you want to download them from the site. All right, thank you.